Good day, ladies and gentlemen. My name is Greg Macneil. I'm a geotechnical engineer with Harbourside Geotechnical Consultants. I've been practicing the geotechnical field for 34 years now, and haven't worked in the on-site systems for probably 25 years, but I spent a few years designing them back earlier in my career. So I was asked by Gary to put together a presentation dealing with soil conditions and problems you have with settlement and just behavior in general of the various soils that you come across in the design and construction of these systems. I have a drawing here that shows conceptual drawing of typical site conditions that you may find when you're putting together a design or construction of an on-site system. So we start at the dwelling, and we have an effluent pipe that leaves the dwelling, feeds a septic tank. You may have a siphon box, pump chamber, an effluent pipe feeding the field, the sand bed of some sort. Typical site conditions throughout Nova Scotia would consist of bedrock, which is usually below any type of construction you're dealing with. If bedrock was at the surface, you would have other problems. Throughout Nova Scotia, most sites are underlain by glacial till. So glacial till within the province can be sort of broken down into two types of materials. One's a sand-based material and the other is clay-based. They both have different characteristics in terms of workability, how you use the material, how you build on the material, how you compact it. On top of the glacial till, often in the back of a dwelling you'll have, or in the front of a dwelling, you'll have a landscaping material, a fill that's used to grade the lot, and a lot of your system may be placed within that fill. That can be variable thicknesses. Sometimes you'll have no fill, but for this discussion we're assuming that there's a fill material, and that's a lot of times where settlement issues would come from. One of the main components of the system is the sand bed, so we'll deal with each of these and how they behave. Most sites there'd be a groundwater table that's hopefully well below your ground surface in order to give you an effective sand bed. So in this case here, our water table is down probably close to our foundation drain and not affecting the conditions up above. Okay, I'm going to talk about soil behavior, the various materials that I've identified here. Bedrock, we won't say too much about that. It shouldn't be an issue. Glacial till. So glacial till is a material that's been deposited during our glaciations, and this material has been overridden by ice. It's had about a mile of ice sitting on it, so it's typically very dense, very good quality material when you're building directly on it. Where you get into trouble is when you take this material, use it as a fill improperly. Fill materials on a site, a fill can be almost as good as a glacial till if it's placed properly, or it can be a pile of rubbish. So when you go on a site that's been previously infilled, you should assume that that material is real poor quality, not suitable for much of anything until you do something to determine whether it is whether it has been placed properly or not. Most grading of dwellings outside of the building itself will be done with very little compaction, if any. It'll be just dumped, graded, and left. The glacial tills, as I talked before, are basically sand and clay based. So the sand will vary from a silty sand to sandy silt, but its behavior is more typical of a sand, and a sand will kind of fall apart and break down into a little pile of dirt, basically. Whereas a clay is plastic, deformable, you can shape it, mold it. It has completely different behaviors and will give you much more difficulty if it's not handled properly. Fill, if not placed properly, can settle under its own weight for several years, and usually when you take a clay-based till and use it as a fill without proper compaction, The clays can behave in a variety of ways, and it's based on the moisture content at the time. We do these tests what's called a Proctor test, and it measures density going up and moisture content increasing this way. And most materials will have a curve that looks like this. And to have the best performance of the material, you want to have a moisture content and density that is at optimum. When the material gets very high in moisture content, it loses strength, and you'll notice when you're placing clay or dealing with clay and driving over when it's wet, it'll be extremely spongy, the trucks will rut it, you get a lot of movement. When the material is very dry, it goes in typically with lumps, and it can look very good when it's being trafficked. It's very solid. These lumps, though, can give you probably more problems than the wet material. Clay that's placed dry and lumpy will look very solid. You can traffic on it very well. It looks like you've got a very good product, but what happens is when it becomes wet after it's been placed dry and lumpy, you've got voids between the lumps. The material will soften and it'll start to collapse. And you'll see this in a lot of subdivision streets where they've worked in the clay tills. Mostly in the summers, what happens, you dig out the material, you stockpile it, lumps of the clay will roll down the stockpile, they'll dry out, you put the material back in the trench, compact it, looks great, it gets wet over several months, and next thing you have a big depression in the road where the trench was. So intuitively, the material looks really good, but it is the one material that will give you the most difficulty when it comes to settlement. So if these fills were placed as a dry till, which is very common, especially if you're doing this work, you know, in the summer months, you're digging your pipe trenches, you're digging out your tanks, you're backfilling with the materials from the stockpile, and if not done at the right moisture content, then you get the settlement problems. So I'll go through some of the areas where you can have settlement issues, and we'll talk about each one. As the effluent pipe is leaving the house, we're crossing over typically, as a minimum, the foundation backfill. And most foundation backfills would consist of a perimeter drainage system that would be clear stone gravel wrapped in geotextile. If that's done properly, there should be no issues associated with that drainage system. The fill on top of that would likely be excavated material from the foundation excavation that had been stockpiled. That stockpiled material, like I said, if it's in a clay-based material, it'll get dumped back against the wall a lot of times without any compaction. It'll go in big lumps, clods. So that zone in there in the backfill is highly susceptible to long-term settlement from addition of water, surface water, wetting these lumps of material, softening them, and you get collapse. So if you go in, dig a shallow trench, put your pipe in it with a little bit of bedding and walk away from it, you run the risk of having this material continuing to settle and causing problems with your pipe. If you do some work and are quite confident, or if you've done the backfilling yourself and you know that this material has been well placed, it's good, competent, compacted soil, then you're probably all right. But you have to assume that that's not very good material when you first get started. So you can get differential settlement near the house from that. And when you get to the tank, often these tanks will be founded deep enough so that they're in the glacial till. There's no reason to get much settlement of that tank. So you're going to get potentially settlement off the fill outside the tank, in the building, differential, no settlement here, no settlement here. The pipe can move in between. So you have to do something to ensure that that doesn't happen. Another issue you can have in between here is you get heat loss from the house that keeps material here from heaving in the frost. As you cross that, you get into material that you get the full 4 feet of frost develop and ground heave, particularly in the fine grained soils that are clay-based tills again, or fills, and you can get maybe as much as 3 or 4 inches. Some of the real silty sands and materials like that, probably more in the Amherst area, are highly frost susceptible, and you can get 5-6 inches of differential movement. So that, in that case, your pipe can actually rise, and then it's fixed at the house, fixed there, and it can rise in between. When you're excavating for these tanks, like I was saying, if you're deep enough and there's not much fill, the tank's probably going to be founded on the glacial till. There's no reason you should have problems with something founded on that material, provided you don't let it get too disturbed when you're working on the base. You clean it out, you tighten up the surface, put in whatever leveling course you need under the tank, and it should be pretty straightforward. If you over excavate, regrade loose material without compacting it, you can get some settlement of the tank. This excavation for the tank and the adjacent pump chamber may be such that the pump chamber or the siphon box is sitting up in the fill, and you have the same conditions there. You have to place that fill, replace it properly, compact it, or else you're going to get settlement and cause this to move differential from this, which causes issues with the effluent pipe in between moving around. As you leave the pump chamber, siphon box, going out into the sand bed, same conditions. You may be partially in fill, you may be in partially in fill and glacial till. It all comes back to the behavior of the fill. If it's been placed previously and it's not good quality, you can have differential settlement along that pipe. And any differential where you're dealing with a low grade on the pipe, it doesn't take much to start to pond water, collect water in the pipe, which causes solids to collect, and that starts problems with plugging of the pipe. So make sure that this fill is looked after. And that may mean if it's garbage, which a lot of times it would be, and at the base of it, they may not have grubbed the original ground surface, so you've got stumps, you've got maybe wet, peaty, boggy areas. You should have good, competent ground below your pipe, or else you run the risk of getting settlement. You move into the sand bed. The sand you want placed as loose as possible in order for it to work as a good filter, having the right permeability characteristics. This type of sand is very susceptible to changes in permeability with compaction. So although settlement is an issue, you will get settlement of sand from being loosely placed and putting this bed within the sand. You'll get maybe 2 or 3% of the thickness of the sand layer under your pipe just from self-weight settlement. That settlement you have to live with, because you don't want to go in here and start compacting that sand bed. The permeability can change 1 or 2 orders of magnitude just through compaction. So everything around this sand bed, and I think the regulations and the guidelines address it, should be done with minimal disturbance to that sand. Light equipment, light tracked equipment, stay off it as much as possible and place the material without driving on it at all if you can. But the settlement that happens there, you're going to live with. Don't be in there compacting it to change the permeability and the effectiveness of the bed. So when placing fill, there's different pieces of equipment that you can use to place it, compact it, and the equipment that's typically used would consist of, say, a jumping jack would be the low-end piece of gear that's often used around some of this type of construction. I really don't like the use of that. That doesn't do much for real compaction. Compaction of these soils typically require weight and vibration, and the vibration is not at the frequency that the jumping jack is working at. It's at about 1,500 cycles per second in that neighborhood. So if you really want proper compaction, you should be using things like the diesel plate tampers or the walk-behind rollers or the whole ram type systems where they use vibration and energy to get compaction. And the type of lift thickness that you should be using for each of the materials will be based on the equipment that you're using. The smaller the compactor, the thinner the lift you should be placing. So I assume most of the construction and backfilling and stuff here, it's not done with a bunch of density readings and site supervision with somebody coming out and measuring the actual density of the material being placed. So it's very important as a contractor to make sure that your material is close to this moisture content, and that moisture content tends to be very similar to the moisture content that the material has naturally. So when it's dug out and you're stockpiling it, you want to try and maintain that moisture as close to that natural point that you possibly can. So that typically means when you're stockpiling the material, stockpile it and try and, maybe either compact the surface of it to keep water from infiltrating very easily and keep the material from forming large lumps that can dry. And then when you dig back into it, if you do have a lot of dry material, don't use it in critical areas. Try and use a material that's at the right moisture content for workability. And when you're dealing with the clay materials, you'll know you're at the right workability when you just get a little bit of deflection off the clay as you're compacting it. It'll start to move a little bit. If it doesn't move and it looks like concrete, it's too dry and lumpy, and that can cause the problems that I talked about earlier. So the lift thickness has to be compatible with the equipment. Make sure you're placing the fill properly against all the backfill around these things, because the pipe has to cross over any of the fill you place. Even if there's no existing fill and you're just digging a hole in the glacial till for the tank, you still have to reinstate that excavation with excavated material, and the effluent pipes are going to be crossing through that, so you have to watch out for that. Another thing that can happen sometimes is if this gravel layer is not properly wrapped with geotextile and you've got a groundwater constantly running in there, surface water, drainage from the roof drains coming in there, you can start to lose material washing into this gravel layer, and that can work into a settlement trough up at the surface, and that's fairly common to see settlement around just from settlement of the fill, but you can also get it from loss of fines into that clear stone. Anytime you're putting in clear stone around a building that's going to be backfilled on top of the clear stone with a fine grain material, you have to have the geotextile there, or you run the risk of losing a lot of your fines into the gravel and pipe. Bedding systems for your pipes, if you're putting in bedding sand, bedding gravel, has to be compatible with the material under it. Sometimes you may be on a site that's backfilled with rock fill, boulder fill, or whatever. You can't put in a sand backfill on top of that material and risk losing all the fines, your sand down in among the voids of the boulders or the gravel or whatever happens to be there. So geotextile separating materials is often the way to deal with that. usually if you've got fine-grained soils derived from the tills and you're putting sands on top of them, there should be no issue with filtration of one material into the other. Another issue that can happen with these materials is trucking to the site and on the site. In the clay tills, with the moisture content, when it gets elevated, and even in some of the sandy, silty sand tills, you will get a lot of movement of the material. You've probably seen it from repeated trafficking. What happens especially in the clays, is you build up pore pressure, it's called, within the sample itself. What that is the weight of the truck is being taken within the water in the soil, and because of the low permeability in the clay, it doesn't let that pressure dissipate. So it'll keep adding and adding under repeated loads, and then all of a sudden you get big deformations starting to happen, big wavy deflections in the subgrade that you're hauling on. And if you have a shallow pipe buried within that material, it will feel those movements as well, and you can break the pipe, you'll deform the pipe, it'll take the shape of whatever the rut and whatever the wave is doing that you're trucking on. So you should plan your hauling and your work so that you're avoiding crossing your pipes for sure, so you don't develop that condition. But that's very common in a lot of these things if you're hauling a lot of materials onto site, on the clays especially. So to summarize, I think the main things to watch for are existing conditions will always cause problems if not looked at in a serious way, to verify that the fills that are already there, if there are fills, are suitable to build on or in. And if not, you have to do enough work to improve them so that it's not going to affect your system. When you're dealing with materials that have the potential to cause problems if not placed right, be cognizant of the moisture content, make sure you're placing it in lifts, compacting it with the proper equipment, and you should have no real problems. Thank you for your time.